name is Nur and I would like to share about what is the nuclear fusion reaction in stars and sun. Nuclear fusion reaction create when two like nuclei fuse together in a fusion reaction. Because of the mass of the resulting single nucleus is smaller than the combined mass of the two initial nuclei, the process produces energy. Remaining mass is converted to energy. Stars, including the Sun, derive their primary energy from a fusion processes. As thermonuclear events and nucleosynthesis affect the composition of stars over an extended period of time, the evolution of stars can be seen as a progression through several stages. Helium is created when hydrogen is burned, which starts stars fusion processes. The fusion processes between the lattice elements that result in the formation of helium are also necessary for the practical generation of fusion energy. Deuterium and tritium, the heavy isotope of hydrogen, react more effectively with one another, and when they fuse they produce more energy per reaction than do two hydrogen nuclei. Researchers began to gain a better knowledge of nuclear fusion in the late 1940s and early 1950s as a result of research projects in the United States, the United Kingdom, and the Soviet Union. They then set out to find ways to use the process for realistic energy generation. The focus of fusion reactor research has been on electromagnetic and magnetic confinement of the extremely hot plasmas required for thermonuclear fusion.
Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to talk about the nuclear reaction in sun and stars. Energy of the star was provided by the nuclear fusion. Proton fusion is the primary fusion mechanism for stars like the Sun, whose core temperature are less than 15 million Kelvin. For more massive stars that are capable of reaching higher temperature, the carbon cycle fusion becomes the predominant mechanism. The triple alpha process, which produces helium by fusion, can be started in order star whose centers are collapsing when the temperature reaches more than 100 million Kelvin. Nuclear fusion activities taking place in the center of Sun give them their immense luminosity. Proton-proton fusion, helium fusion, or the carbon cycle can all produce energy depending on the age and mass of the star. Nuclear fusion activities taking place in the centers of Sun give them their immense luminosity. Heavy element up to iron may fuse briefly toward the ends of a star's lifetime, but since the group of elements has the highest binding energy, fusion of elements with masses greater than iron would absorb energy rather than produce it. Heavy metals are produced in stars via a different class of nuclear processes, but the iron group represents the highest limit of fusion energy yet. Lastly, instead of producing energy, this nuclear synthesis of atoms heavier than iron consume it.
Okay, let's look at the hydrogen fusion. Okay, hydrogen fusion is the fundamental nuclear reaction in stars. Okay, as we know, any star that is fusing hydrogen in its core is known as a main sequence, and our star is a main sequence star. Okay, the two most important reactions that fuse hydrogen into helium are pp chain and CNO cycle. Okay, pp chain stands for proton-proton change. In this reaction, 4 hydrogen nuclei combine to form one helium nucleus as shown in the photo given. So in this reaction, 2 protons come together and form a deuterium nucleus. Okay, deuterium nucleus has one proton and one neutron. This is two-step process. First, two protons combine to form a diproton. Then one of the two protons change into a neutron by releasing a positron and neutrino. Okay, on this deuterium, another proton attacks and form helium-3 as shown above. This helium-3 combine with another helium-3 produce parallel twin and form a helium-4 nearby, releasing two hydrogen atoms as shown in the photo given. CNO stands for carbon neutron oxygen. The CNO cycle is yet another nuclear reaction by which stars produce helium from hydrogen using carbon, nitrogen and oxygen as catalysts. The CNO cycle is a dominant source of energy for stars that are about 1.3 times more massive than the Sun. This reaction becomes dominant at about 17 million K. The core temperature of Sun is 15 million K and plus PP chain is the dominant reaction. Lastly is helium fusion. Okay, in the helium fusion, there is a triple alpha process. Okay, once all the hydrogen has been converted into helium in the core, it is time for the next nuclear reaction. After helium, carbon forms via the triple alpha process. This reaction is simple. Two helium-4 nuclei come together and form beryllium 8. This beryllium 8 nuclei is further attacked by a helium-4 and forms a stable carbon-12 as shown in the photo given.
Just now, we heard the explanation about the nuclear fusion occur in sun and star. Now, we focus on what happens if the sun do not undergo nuclear fusion, and will the sun ever stop shining? Okay, if the sun do not undergo nuclear fusion, there would be no life of Earth. We have to know, because of the fusion reaction in the core of sun, we can see light and feel as warm. Other than that, we already know the sun is the source of the all energy. It means that if the nuclear fusion does not occur in the sun's core, we will no longer have a source of energy to power our Earth. Next, will the sun ever stop shining? The answer is yes. Okay, we know that stars shine because a huge amount of energy created by nuclear fusion. However, scientists said in about 5 billion years, the hydrogen in the sun's core will run out. It means that the sun will not have enough fuel for nuclear fusion to occur. Because of that, the sun will stop shining in about 5 billion years.
For the conclusion, nuclear interaction between light elements that create heavier elements were releasing enormous quantities of energy. Hans Bethe proposed in 1939 that the fusion reaction between hydrogen nuclei are responsible for the energy production of the sun and other stars. American scientists created the hydrogen bomb in the early 1950s by initiating fusion event in a mix of deuterium and tritium, which resulted in a formation of a heavier helium nucleus. Although fusion occurs often in the sun and other stars, it is challenging to artificially manufacture, and it is highly challenging to regulate. If controlled nuclear fusion is success, deuterium can be extracted from regular water, and that 8 gallons of water have the energy density of 2,500 gallons of gasoline. It may offer a cheap source of energy since the primary fuel. Both the energy yield and the pace of nuclear reaction are significant factors. This number have a significant impact on the field of science like nuclear astrophysics and the possibility of nuclear energy generation. The main energy source of stars fusion processes also serve the mechanism for the nuclear synthesis of the like elements. Lastly, reaction between deuterium and tritium are the most important fusion reaction for controlled power generation because the cross-section for their occurrence are high. That's all. Thank you.